Hey, what's up guys, hope you are doing well. I'm Arvind from Precision Data Science. Today we'll try to build a machine learning model to predict the African banking crisis. In this dataset we have various crisis data belonging to 13 African countries. So let's buckle up and without further ado, let's dive into the video. So first we are going to import necessary libraries such as NumPy pandas to work on the array data and the data frame. Next we have matplotlib and seaborn for data visualizations, and we are going to import warnings to ignore the warnings and have a cleaner output. We're going to read the CSV file using read_CSV method and assign it to a variable df. Next, with the df.head method, we are going to look at the first few rows of the data frame, and also we have all the columns. So in this data set we have case, CC3, country, systemic crisis, domestic debt default, and then we have currency crisis, inflation crisis, and the banking crisis. So with the info method we are going to look at the total number of entries, that is 1059, and we're going to look at the non-null count, that is 1059 for all the columns, which means that we don't have any missing data. Next we have the data type, that is integer, object, and float data type for various columns. With nUnique method we are going to look at the number of unique values in each column. For example, for the case we have 13 unique values, for the CC3 and for country we have 13 unique values, and for the rest of the columns we have 772, 2, 6, and 1022. We're going to run the unique method for the case, CC3, and the country column and look at the unique values. So here, as you can understand, we have different case numbers and corresponding CC3, that is I think the country code for these countries. For example, we have CAF country code for the Central African Republic, and we have MUS for Mauritius, etc. So these three columns can be represented by a single column, that is country. We can quickly drop the case column, which is nothing but the case numbers, and the CC3, that is the country codes. So after dropping, we'll look at the data frame. Here we have 1059 rows and 12 columns, which excludes the case and CC3. Now with the df_info method, we are going to look at the data types. Here we have object data type, integer data type, and float data type. So in order to run the machine learning model, we should be having the numerical data type. So we are going to convert the country column and banking crisis columns data types. In order to convert this data type into numerical data type, we are going to import the label encoder from the scikit-learn library. We are going to instantiate the label encoder and fit transform for the country and the banking crisis columns. So after transforming, we'll look at the data frame. Here we can see that we have 13 different country values, and for the banking crisis we have 2 values. Now let's look at the value counts for the banking crisis. And here we have 965 values belonging to class 1 and 94 values belonging to class 0. So clearly we have imbalance, which we are going to address later. So before that, first we are going to divide the dataset into features and target. For the features, we are going to consider all the columns except the banking crisis column, and for the target we are going to consider only the banking crisis. We look at the features, that is X. We have all the columns except the banking crisis, and for the target we have the banking crisis data. Next we are going to split the data into training set and testing set. What happens is, for the machine learning model, it is going to train on the training set and then it's going to test on the testing set. So it is going to apply certain correlation with respect to the training set, and it is going to predict based on these correlation to the test set. So in order to split this data, we are going to import train test split from the scikit-learn library. And for splitting, we are considering 20% for the test size and 80% for the training size. And we are going to consider a random state of 79. So now we'll look at the value counts for the training set. As you can see, we have 782 values belonging to class 1 and 65 values belonging to class 0. So clearly there is an imbalance. Now in order to address this imbalance in the training set, we are going to import smooth technique, that is going to create some synthetically optimize the minority samples and try to fit with the majority class. So we'll instantiate the smooth technique with a random state 79, and we are going to fit resample for the training set. So after resampling, we'll be able to look at the values. Yeah, we have 782 values belonging to 1 and 0. So basically what it has done is it has resampled and created additional values for the minority class, and it has equalized the values so that we'll have the equal distribution of both the classes. Now next we'll look at the test set. For the test set, we are able to look at the imbalance again. Here we have 29 values belonging to class 0 and 183 values belonging to class 1. But in this case, we are not going to apply smooth technique, because since it's a test data, we should not be touching it and we should not be making any manipulations for the test data. Next, we'll try to build the random forest model. So in order to build the random forest model, first we'll import the random forest classifier from the scikit-learn library, train our model with random forest classifier and a random state 79. We'll fit the random forest algorithm to the training set. So which is basically going to create the ensemble of decision trees collaborating through the majority class voting, and it is going to make a robust and accurate predictions. So random forest is basically like a forest of various decision trees, and they are going to create some voting system and try to make predictions. Okay, we'll fit the data to the machine learning model, and next we are going to predict the trained model for the test set. So in the test set, we have X test as the features and Y test as target. So when we fit the machine learning model to this training set, it is going to learn the parameters which is going to predict the target variables. Next, with the predict method for the X test, we are going to predict and assign it to variable ypred. Now in order to evaluate these results, we are going to have certain metrics. For this, we are going to import accuracy, F1 score, classification report and confusion metrics from the scikit-learn library. First, we're gonna check the accuracy score, which is nothing but the accuracy of the model to predict correct predictions. We have a high accuracy of 97.64%. It has predicted accurately because since we have a small data set and the machine learning model is able to readily learn with a high accuracy. Next, we have macro averaged F1 score, which is nothing but harmonic mean of precision and recall. Here we are considering the macro average, which is going to represent both the classes 0 and 1. Now for the F1 score, we have 95%, which is again a high value for the given small data set. Next, we'll quickly look at classification and the confusion metrics. So here with the classification report, we'll be able to look at the precision, recall and F1 score, and also precision, recall, F1 score belonging to class 0 and class 1. As you can understand, we have an accuracy of 98% and the F1 score of 95%. For the confusion matrix, we'll again run the confusion matrix and then we'll create a heat map for better data visualization. Here we have one false positive, which is type 1 error, and we have 4 belonging to false negative, which is type 2 error, and rest all are predicted positively. Next, we are going to look at test set. Here we have the features. We have certain index 879, 616, 53, etc. and we have columns, and with y-test we have the target variable. So we are going to test the given model, trained model, and predict on random data. So for that, first we'll import the random, and we can go with the random choice from the x-test, or we can manually select certain data points from the given x-test and the y-test. So for example, we'll assign 53 to a random index, and we are going to reshuffle the x data for the random index so that it is going to fit the machine learning model. Next, we are going to create a prediction label for the given random data point, and we are going to check the actual label for the given random index. When we check, we are able to look at the features of the random index, that is 53, and the predicted label for the trained model is 1 and the actual label is 1. Since we have made a correct prediction, we'll try to make another prediction. Let's say with class 0, we'll type 1049 as the random index and we'll predict it. As you can see, the model correctly predicts actual label, that is 0. Since it's a small data set, we are able to make accurate predictions. If you enjoyed this video so far, please like the video, subscribe and hit the bell icon to see more content. Thank you.